Right now, as you sit in your room, a massive world made almost entirely of pure carbon is screaming through space around the crushed core of a dead star. This giant planet orbits so close to its host that an entire year passes in less than 8 hours. Intense radiation is constantly blasting its surface with enough violence to vaporize solid rock. Yet against every single law of astrophysics we have ever written, this impossible world continues to exist. If you love uncovering the real, mind-bending secrets of the universe without any clickbait or exaggeration, hit that subscribe button right now. We dive deep into genuine cosmic mysteries every single week, so you can be the first to know what is truly happening out there in the dark. For hundreds of years, scientists thought they had a complete handle on how planets were made. They looked at our own solar system and saw a very neat and clean pattern. Close to the Sun, you have small, rocky worlds like Mercury, Venus, Earth, and Mars. Further out, beyond the freezing boundary known as the snow line, you have huge gas giants like Jupiter and Saturn. This picture was so tidy that it became the foundation for all modern planetary science. The basic theory was called core accretion, and it seemed completely bulletproof. According to this model, every solar system starts out as a giant spinning cloud of gas and dust called a protoplanetary disk. Over millions of years, tiny bits of dust stick together to form pebbles, then rocks, then massive boulders. If a growing planet gets big enough, fast enough, its gravity starts pulling in huge amounts of gas from the surrounding disk. But there was always a strict cosmic limit built into this math. To build a giant gas planet, you need a giant star with a huge, heavy disk of material. A small star simply would not have enough leftover dust and gas to build anything bigger than a rocky world like Earth. For a long time, every telescope we pointed at the night sky seemed to confirm this rule. Small stars had small planets, and big stars had big planets. It made total sense, and astronomers felt confident that the universe followed these clean, simple guidelines. But as our technology got better, we started finding weird clues that our rules were far from complete. When NASA launched space telescopes like Kepler and the Transiting Exoplanet Survey Satellite, also known as TESS, they began detecting thousands of worlds outside our solar system. Scientists were shocked to find hot Jupiters, which are massive gas giants orbiting right next to their stars where they should have melted away. They also found rogue planets wandering alone in the deep dark without any star at all. These strange discoveries showed us that space is far wilder than our computer simulations ever predicted. Yet even with those strange worlds, the basic rule of star size and planet size still seemed to hold strong. No astronomer expected to find a gas giant orbiting a star that was too tiny to create it, until the James Webb Space Telescope turned its massive golden mirror toward a quiet corner of our galaxy. Did you know that back in the 1990s, scientists were convinced we would never be able to see the atmosphere of a planet in another solar system? What do you think is the most surprising thing we have found in deep space so far? Drop your thoughts in the comments below and tap that like button if you love learning about real space discoveries. The story of the first impossible world centers on a small red dwarf star located about 280 light-years away from Earth. This star is known to astronomers as TOI 525 or TOI 5205. Red dwarf stars are the most common stars in the entire Milky Way galaxy, but they are also absolute quiet underdogs. They are much cooler, dimmer, and lighter than our Sun. In fact, this specific star has only 39% of the mass of our Sun. Under all traditional rules of space science, a star that small should only be able to create small, rocky planets. Its original disk of dust would have been far too thin and lightweight to gather enough gas for a giant planet. But when astronomers looked closer at the data, they noticed something that made them double-check their calculations. The star was dimming dramatically every few days, as if a monster was passing right in front of it. When they measured the object causing the shadow, they could hardly believe what they were seeing. Orbiting this tiny red dwarf star was a massive gas giant named TOI 525b. This planet is nearly the exact same size as Jupiter, meaning it is more than 1,000 times bigger than Earth. To put that into perspective, the planet is almost as large as the star itself. Imagine a bowling ball being orbited by a giant grapefruit. In our solar system, the Sun is like a massive basketball, and Jupiter is like a tiny marble. But in the TOI 525 system, the planet takes up so much room that it covers over 6% of the starlight every time it passes by. That is one of the largest dips in brightness ever recorded for a normal star system. Scientists immediately labeled TOI 525b a forbidden planet. According to every computer model ever built, the star simply did not have enough raw materials in its birth disk to make a core big enough to trap that much gas. It was like finding a fully built skyscraper in the middle of a tiny backyard shed. The math just did not add up. Researchers tried to explain it by guessing that maybe the planet formed somewhere else and got captured by the star later. Or perhaps two smaller planets smashed together in a violent crash and somehow triggered a runaway growth spurt. But none of those ideas quite fit the facts. Astronomers needed a much more powerful eye to peek through the haze and see what was actually going on inside this forbidden system. Have you ever seen an outcome in nature that seemed to break every single rule you were taught in school? If this strange cosmic puzzle is blowing your mind, please leave a quick comment with the word puzzle so I know you are enjoying the journey. Do not forget to hit subscribe so you never miss another deep dive into the mysteries of our universe. That is where the James Webb Space Telescope came in. Launched on Christmas Day in 2021, James Webb is the most complex and powerful space observatory ever constructed by human hands. It orbits the Sun 1 million miles away from Earth, sitting in a freezing cold region of space where it can look at the cosmos in infrared light. Unlike older telescopes that look at visible light, James Webb can look right through thick clouds of cosmic dust. It can measure the heat signatures and chemical fingerprints of objects billions of light years away. When astronomers pointed James Webb at TOI 525b, they were hoping to solve the mystery of how this giant planet could possibly exist around such a small star. What James Webb found only made the mystery deeper and stranger. Using its special instruments, the telescope scanned the atmosphere of the planet as starlight filtered through its outer gas layers. Astronomers expected the planet to be rich in heavy elements like carbon, oxygen, and iron, which are usually required to build a giant planetary core. Instead, James Webb revealed that the upper atmosphere of TOI 525b was shockingly poor in heavy elements. It was made almost entirely of light hydrogen and helium gas, with very low amounts of heavier chemicals. This meant the outer shell of the planet was completely different from what scientists expected based on its host star. At the same time, measurements of the planet density showed that its deep inner core was likely packed with heavy rocks and metals. This created a huge contradiction. The deep inside of the planet looked like it formed one way, while the outside layers looked like they belonged to a completely different type of world. It was as if the planet had grown up in two totally different environments at the same time. Before this discovery, scientists thought planets mixed their atmosphere and core materials together as they grew, but TOI 525b proved that giant planets can form in ways we never thought possible. It forced scientists to go back to the drawing board and rethink the basic physics of how gas giants grow in low-mass star systems. Another planet that smashed scientific expectations around the exact same time is known as LHS 354b, or LHS 3154b. This planet was discovered orbiting an ultra-cool dwarf star located 51 light-years away from Earth. The star, LHS 3154, is 9 times less massive than our Sun, making it a tiny, dim cosmic spark. Yet orbiting this tiny star is a planet 13 times more massive than Earth, very similar to Neptune in our own solar system. The ratio between the mass of LHS 3154b and its parent star is 100 times greater than the mass ratio between Earth and the Sun. To build a core that heavy, the dust disk surrounding the young star would have needed to be 10 times more massive than anything we have ever observed around a dwarf star. When scientists ran computer models to see if LHS 3154b could form naturally, every single simulation failed. The star simply lacked the physical ingredients to build such a giant world. Finding 2 of these impossible worlds in such a short period proved to astronomers that these were not just accidental glitches. There is an entire population of giant planets orbiting tiny stars across our galaxy, and our theories of planet birth are missing something massive. If you could travel on a spaceship to visit any weird world in the galaxy, would you pick a giant planet orbiting a tiny red dwarf star? What do you think keeps these strange worlds together against all odds? Tell me your favorite destination in the comments, and hit the subscribe button if you want to keep exploring the deep secrets of the cosmos with us. As shocking as these forbidden planets around small stars were, they were only the beginning of what James Webb was about to uncover. To understand the next level of this mystery, we have to look at what happens when stars die. When a star like our Sun runs out of fuel billions of years from now, it does not just quietly turn off. It expands into a massive, glowing red giant star that swallows everything nearby. During this terrifying red giant phase, the star grows to hundreds of times its original size. In our own solar system, when the Sun becomes a red giant in about 5 billion years, it will expand so far that it will engulf Mercury, Venus, and almost certainly Earth. The heat and gravitational pull during this transformation are so intense that any planet caught inside the expanding star is ripped apart and vaporized into dust. After the red giant blows off its outer layers, all that is left behind is a tiny, super-dense core called a white dwarf. A white dwarf is about the size of Earth, but it packs the mass of an entire star inside that tiny space. Because the star went through such a destructive death, scientists assume that no close-in planet could ever survive the transition from a living star to a white dwarf. Any planet orbiting close to the star would have been dragged into the fiery red giant atmosphere and burned to ash long before the white dwarf was born. So when astronomers found a gas giant planet orbiting extremely close to a white dwarf named WD 1856, they were stunned. The planet, known as WD 1856b, is about the size of Jupiter and completes a full orbit every 34 hours. It orbits at a distance of less than 2 million miles from its dead star. For comparison, Earth orbits 93 million miles away from the Sun. If this planet had been at its current distance while its star was dying, it would have been floating deep inside the burning guts of the red giant. It should have been destroyed in a matter of days. Yet there it was, calmly circling a dead star as if nothing had ever happened. Scientists realized the planet must have originally lived much further away in a safe, distant orbit. Then, after the star died and became a white dwarf, something must have kicked the planet inward toward the dead core. But how could a planet migrate all the way inward without getting shredded by tidal forces? That was the puzzle James Webb was sent to solve. How scary is it to think that our own Earth will one day face the expanding red giant phase of our Sun? Do you think humanity will find a way to travel to another star system before that happens? Share your thoughts below and smash that like button to help more space lovers find this channel. When James Webb observed WD 1856b, it measured the temperature and atmosphere of the planet to figure out its history. The data showed that the planet was relatively cool and had survived the violent death of its host star without losing its light atmosphere. Computer simulations powered by James Webb findings suggested that other undiscovered planets in the outer edges of the system had nudged WD 1856b with their gravity. This gravitational dance pushed the giant planet into a long, stretched-out orbit that brought it close to the white dwarf without smashing directly into it. Over millions of years, the gentle pull of the white dwarf rounded out the planet orbit, parking it safely in a super-tight circle. This proved for the very first time that gas giant planets can survive the death of their stars and settle into new orbits around white dwarfs. This discovery gave scientists new hope for the far future of solar systems like ours. It proved that even when stars die in massive fireballs, planets in the outer regions can survive and even move closer to the leftover embers. But as incredible as the story of WD 1856b was, James Webb was about to find something even more terrifying. A world that was not just surviving around a dead star, but orbiting a cosmic monster. This next discovery brings us to the most extreme object in the entire universe, a millisecond pulsar. When a supermassive star dies in a huge supernova explosion, its core collapses into a neutron star. These objects are so dense that a single teaspoon of neutron star material would weigh billions of tons on Earth. Some neutron stars spin hundreds of times every single second, blasting intense beams of high-energy radiation out from their poles like a cosmic lighthouse. These are called pulsars. Pulsars emit deadly gamma rays and X-rays that strip away atmosphere and destroy everything in their path. Sitting near a pulsar is like standing right next to a nuclear blast that never stops. In some rare cases, a pulsar is paired with a companion star in a binary system. The pulsar uses its massive gravity to suck material away from the normal star, slowly eating it alive. Scientists call these terrifying systems black widow pulsars, named after the spider that eats its mate. Over millions of years, the pulsar devours almost the entire companion star, leaving behind only a tiny, crushed core. Are you finding this journey into the extreme corners of space exciting so far? If you could ask a NASA scientist one single question about these extreme worlds, what would it be? Type your question in the comments section below and subscribe if you want to stay updated on all the newest telescope discoveries. Astronomers recently turned the James Webb Space Telescope toward a famous black widow system named PSRJ 2322-2650. In this system, a pulsar spinning hundreds of times per second is orbited by a companion object called PSRJ 2322-2650b. This planet-sized remnant is about the size of Jupiter, but it orbits the deadly pulsar at a mind-boggling speed. It takes just 7.8 hours for this world to complete a full trip around the dead star. That means its entire year is less than a single workday on Earth. The planet sits only 1 million miles away from the pulsar, subjecting it to extreme gravitational pull and radiation that should have vaporized it long ago. According to existing scientific models, the intense gamma radiation from the pulsar should have completely boiled away the companion star outer layers, leaving behind a ball of pure helium gas. Scientists were confident that if any planet-sized remnant survived, it would be made almost entirely of helium. But when James Webb pointed its powerful spectrograph at the object, the data revealed something that left astronomers completely speechless. The atmospheric readings did not show helium at all. Instead, James Webb revealed that the atmosphere of this planet was composed almost entirely of elemental carbon. The telescope detected complex carbon molecules like dicarbon and tricarbon floating in the air. The ratio of carbon to oxygen on this world was measured to be over 100 to 1. To understand how insane that number is, Earth has a carbon to oxygen ratio of less than 0.01. This world had 10,000 times more carbon relative to oxygen than our own planet. It was a planet with an atmosphere made of pure carbon soot, floating in space around a dead, deadly star. Because of the high pressure and extreme heat, scientists believe that beneath this thick soot atmosphere lies a giant interior made of solid diamond. The gravity of the pulsar is so strong and the pressure inside the planet is so immense that the carbon atoms are crushed into a giant crystal structure. It is, quite literally, a world-sized diamond orbiting a zombie star. Does the idea of a giant planet made of diamond orbiting a deadly pulsar sound like pure science fiction to you? What kind of wild landscapes do you imagine exist on the surface of a carbon world? Let me know your thoughts in the comments, and hit the subscribe button if you want to keep exploring the deep secrets of the cosmos with us. The details uncovered by James Webb on this carbon planet get even stranger the further you look. Because the planet orbits so incredibly close to the pulsar, it is tidally locked. This means the exact same side of the planet always faces the pulsar, while the other side is permanently trapped in pitch-black darkness. The day side of the planet is blasted by continuous radiation, heating temperatures up to over 3,600 degrees Fahrenheit. On this burning day side, James Webb detected clear chemical signatures of hot carbon molecules swirling in the air. But when the telescope looked at the night side, the chemical signatures vanished completely. The night side of the planet appears to be completely featureless, covered in a freezing layer of thick black carbon soot that absorbs almost all light. Even more amazingly, James Webb tracked the heat signature across the surface and found that the hottest spot on the planet is shifted slightly to the west of center. This provided the very first direct observational proof of super-powerful equatorial winds blowing west across an alien planet atmosphere. Winds made of carbon soot are whipping around this diamond world at thousands of miles per hour, carrying heat from the day side to the night side. Yet the biggest question remains completely unanswered. How could a carbon atmosphere survive here at all? The pulsar radiation should have burned away all the light carbon gas millions of years ago. Some scientists guess that two white dwarf stars made of carbon smashed together in the past, creating a weird hybrid object that was later captured by the pulsar. Others think that deep internal processes inside the planet are constantly pumping fresh carbon gas out from the interior to replenish the atmosphere as fast as the pulsar destroys it. But no current computer model can fully explain the extreme carbon numbers measured by James Webb. It is a planet that fundamentally breaks our understanding of how chemistry works in extreme space environments. What do you think is driving these powerful carbon winds across the dark side of this planet? Do you think we will ever send robotic probes out to these extreme pulsar systems to take close-up pictures? Drop a comment below with your best theory, and hit that subscribe button to stay updated on all space news. As if diamond planets and forbidden gas giants were not weird enough, James Webb has also turned its gaze toward planets that break the rules of density. Consider the shocking case of WASP 193b, a planet located 1,200 light-years from Earth. This planet is 50% larger than Jupiter, making it a huge target in space. Yet when astronomers calculated its total weight, they found that it is 7 times lighter than Jupiter. In fact, WASP 193b has a density of just 0.05 grams per cubic centimeter. For comparison, Earth has a density of 5.5 grams per cubic centimeter, and water has a density of 1 gram per cubic centimeter. This planet is lighter than cotton candy. It is so light and fluffy that if you could somehow build an ocean big enough to hold it, WASP 193b would float on top of the water like a giant balloon. Astronomers have no complete explanation for how an atmosphere can expand to such a huge volume without stripping away into empty space. When James Webb looked at WASP 193b, it detected water vapor and carbon dioxide floating in a superheated, super-thin atmosphere. The heat from its nearby star is puffing the planet up, but standard physical models say that heat alone is not enough. There must be an internal heat source, like radioactive decay or intense gravitational flexing, pumping continuous energy into the planet interior. Another mind-bending discovery made by James Webb involves the planet TOI 1130b, or TOI 1130b. In astronomy, there is a famous rule called the Bully Rule of hot Jupiters. Whenever a giant planet like Jupiter migrates close to its star, its immense gravity kicks out or eats every smaller planet in its path. Hot Jupiters are almost always completely lonely systems. Yet when James Webb looked at TOI 1130, it found a massive hot Jupiter orbiting the star every 8 days. And right inside its orbit, completing a lap every 4 days, was a mini Neptune planet that should have been kicked into deep space billions of years ago. They are living right next to each other in total harmony, completely defying the gravitational bully rule. When James Webb analyzed the atmosphere of this mini Neptune, it found rich chemical clues showing that both planets formed together far out in the cold regions of their disk and moved inward as a team. Instead of destroying its neighbor, the hot Jupiter protected it, showing that planetary migration can happen in peaceful ways we never imagined. How cool is it that a giant bully planet could actually act like a shield for a smaller world? Do you think there are other solar systems out there with even crazier family arrangements? Leave a comment below with your thoughts and tap the subscribe button to keep uncovering these real cosmic surprises. These incredible findings show us that what is happening right now in space science is a total revolution. For decades, we relied on simple theories that were based only on the few planets in our own solar system. We assumed that our cosmic neighborhood was the standard template for the rest of the universe. But James Webb is proving every single day that the universe does not care about our neat little categories. Right now, as you watch this, astronomers are analyzing new data flowing in from James Webb every hour. They are finding giant planets hiding inside dusty disks of young stars like Beta Pictoris, where planets are actively taking shape right before our eyes. They are discovering third and fourth planets hidden deep inside star systems that we thought we had already fully explored. They are using spectroscopy to read the atmospheric barcodes of worlds buried in blinding starlight and thick cosmic fog. Every time James Webb points its golden mirror at a new target, it seems to find something that challenges our books. From giant gas worlds orbiting tiny red dwarfs, to planets surviving the fiery deaths of white dwarfs, to diamond worlds trapped in the lethal embrace of black widow pulsars. This is not just historical facts from the past. This is an active, ongoing mission unfolding right now in 2026. Every single new dataset forces scientists to rewrite code, redesign simulations, and throw out decades of old assumptions. The universe is far more creative, violent, and diverse than any human imagination could ever dream up, and we are lucky enough to live in the exact era where we finally have the tools to watch it all happen in real time. When you step back and look at all these impossible planets, it changes the way you view our place in the universe. For a long time, humans thought Earth was special because it was solid and had liquid water. Then we realized that rocky planets are everywhere. But seeing how wild, violent, and bizarre most solar systems really are gives you a brand new perspective. Our solar system, with its calm circular orbits and comfortable middle-aged sun, might actually be one of the rare, peaceful oases in a galaxy full of chaos. While other planets are being roasted by pulsars, dragged through red giant fires, or forced into bizarre shapes by extreme gravity, Earth sits in a perfect sweet spot. Understanding these extreme worlds is not just about satisfying our curiosity about distant stars. It is about understanding the ultimate fate of our own home. By studying planets around dead stars, we are getting a preview of what will happen to our solar system billions of years from now. By studying how atmospheres survive intense radiation, we learn how to search for truly habitable worlds that might host alien life. Every impossible planet James Webb discovers brings us one step closer to answering the ultimate human question: are we alone in the dark, or is the galaxy teeming with strange life adapting to wild environments? The universe is full of mysteries waiting to be solved, and we are only getting started. If you enjoyed this journey into the impossible worlds found by James Webb, please subscribe to the channel right now and turn on all notifications so you never miss a new video. I want to hear from you down in the comments. Which of these impossible planets surprised you the most? The giant planet orbiting the tiny star, the planet that survived a red giant explosion, or the diamond planet orbiting a pulsar? Drop your answer in the comments below and share this video with a friend or family member who loves space as much as you do. Thank you so much for watching, keep looking up at the stars, and we will see you in the very next story.